This is 8.3, part 4. Let's continue simplifying. For this one, I have a square on the inside. Remember, your index is an understood 2. 2 divides into 2 one time, so I have a b to the understood first power on the outside. 2 is prime, so that radical does not simplify. I have no more b's left since it divided in evenly, so I have b times the square root of 2. Plus 3b times. Simplify the square root of 18. I know we have 18 on here somewhere. It's right in here. If you cover up everything above the 18, the square root of 18 would be, have a pair of 3's, and have a square root of 2 left over. So it's 3 times the square root of 2. Minus b times the square root of 200. We have done a prime factorization of 200. We used it for a cube root before, but we can use the same prime factorization for a square root. I'd be looking for pairs. Here I have a pair of 2's, and then I have a pair of 5's. So a 2 comes out, a 5 comes out. 2 times 2 would be 2 times 5 would be 10. And then I had a 2 left over. So that is 10 times the square root of 2. Okay, now let's multiply in front. There's nothing to simplify here. B square root of 2 plus 3b times 3 would be 9b square root 2 minus, this is 10b square root of 2. Now, that is an understood 1 right there. Let's look. I have a b in front on all of these. I have square root 2 on all of these, so I'd be able to combine them. So this is 1 plus 9 minus 10. Well, that's 10 minus 10, which is 0. Now, what do we do if we have a 0 in front? Well, that's like 0 times b times the square root of 2. Because it would just be the number in front, and those are multiplications, right? But anything I multiply by 0 is just 0. This whole thing cancels out. If you have some trouble seeing this, think of it this way. Since these three things are the same, we basically have this pattern. X plus 9x minus 10x. It's a little bit easier for us to see that 10x minus 10x, those cancel out. Okay, so this whole answer is just 0. It went away completely. Now, your calculators can't handle variables, so you do need to know how to do this by hand. Okay, so let's look at this one. 2 times the square root of 125x squared z plus 8x times the square root of 80z. All right, so let's look at this. All right, I have a 2 in front. Let's just move that in front. All right, let's deal with the number in a second. Here I have x squared, and that's an understood 2 there. 2 divides into 2 one time, so I'm going to have an x here on the outside. I might have a number, so I'm leaving myself a little bit of space. And then I don't have any x's left on the inside. But I am going to have a z on the inside because there's only one of these, and so I can't take any out. So I know I might still have a number inside. I'm leaving myself space here. But I'm going to have something like that. So let's look at the square root of 125. Do we have 125 on here anywhere? I don't think so. So 125 is divisible by 5. If I do that, I get 25, which is also divisible by 5, which leaves me with a 5. So the square root of 125 is going to equal, I have a pair of 5's, and then I have a 5 left over. So 5 times the square root of 5. So a 5 on the outside, a square root of 5 on the inside. So let's talk through this again. One of these, I had 2 of these, so that was a pair of x's, so 1 came on the outside. The square root of 125 is 5 times the square root of 5. I had a z alone, so it is stuck on the inside. Okay, so plus 8x times, I have a z alone on the inside, so I'm still going to have that z on the inside of the square root. Let's look for prime factorization of 80. Do I have 80 anywhere? Yes. Square root of 80. I did the fourth root of 80 before, but we can use the same thing. The square root of 80. I have a pair of 2's. I have another pair of 2's. 2 times 2 is 4, so I have a 4 on the outside, and then I have a 5 left over. So 4 times the square root of 5. So 4 times the square root of 5, and then I have that z still there. All right. 2 times 5 would be 10x times the square root of 5z, plus 8 times 4 would be 32x times the square root of 5z. So let's see if we can combine these. I have exactly the same radical with the same number and the same variable raised to the same power. It's exactly the same. I also have to check my variables in front, and I have an x on each of them, so those are okay. So I can add 10 plus 32 to get 42, and then I keep x times the square root of 5z.